Welcome to the birth and death of stars, a journey through stellar evolution. In this video, we will explore the fascinating world of stars and their life cycle. Stars are not just bright, twinkling objects in the sky, but they are also the building blocks of the universe. They are responsible for creating the elements that make up everything around us, including ourselves. A beautiful shot of the night sky with stars twinkling, followed by a zoom in on a star. But have you ever wondered how stars were born and how they die? In this video, we will take you on a journey through the different stages of stellar evolution, from the birth of a star to its eventual death. An animation of a star being born from a cloud of gas and dust. Stars are born from clouds of gas and dust, called nebulae. These nebulae are made up of hydrogen, helium, and other elements. Over time, gravity causes these clouds to collapse, and as they do, they become denser and hotter. An animation of a nebula collapsing and becoming denser and hotter. As the cloud becomes denser, it begins to spin, forming a disk-like structure. In the center of this disk, the temperature and pressure become so high that nuclear fusion begins to occur. An animation of a disk-like structure forming around the center of the cloud, followed by an animation of nuclear fusion occurring. Nuclear fusion is the process by which hydrogen atoms combine to form helium, releasing a tremendous amount of energy in the process. This energy is what makes the star shine. An animation of nuclear fusion occurring, followed by a shot of a star shining brightly. The star continues to shine for millions or even billions of years, depending on its mass. But eventually, all stars must come to an end. An animation of a star aging and eventually dying. In the next segment, we will explore the different stages of a star's life and how they lead to its eventual death. In the previous segment, we learned about how stars are born from clouds of gas and dust and how nuclear fusion occurs in their cores, making them shine. In this segment, we will explore the first stage of a star's life, known as the main sequence. An animation of a star in the main sequence, with its core shining brightly. The main sequence is the longest stage in a star's life, lasting for millions or even billions of years. During this stage, the star is in a state of equilibrium, with the inward pull of gravity balanced by the outward pressure of the energy produced by nuclear fusion in its core. An animation of the inward pull of gravity being balanced by the outward pressure of nuclear fusion. The size and temperature of a star on the main sequence depend on its mass. Smaller stars, known as red dwarfs, have lower temperatures and shine less brightly than larger stars, such as blue giants. An animation comparing the size and temperature of red dwarfs and blue giants. As a star ages in the main sequence, it slowly runs out of hydrogen fuel in its core. When this happens, the balance between gravity and pressure is disrupted, and the star begins to evolve. An animation of a star's core running out of hydrogen fuel and the star beginning to evolve. In the next segment, we will explore the different paths that a star can take as it evolves and how they lead to its eventual death. In the previous segment, we learned about the main sequence, the longest stage in a star's life, during which it is in a state of equilibrium, with the inward pull of gravity balanced by the outward pressure of nuclear fusion in its core. As a star ages on the main sequence, it slowly runs out of hydrogen fuel in its core, and the balance between gravity and pressure is disrupted, causing the star to evolve. An animation of a star evolving, with its core collapsing and heating up. The path that a star takes as it evolves depends on its mass. Smaller stars, such as red dwarfs, evolve differently than larger stars, such as blue giants. An animation comparing the evolution of red dwarfs and blue giants. When a red dwarf runs out of hydrogen fuel in its core, it simply cools down and becomes a dimmer, cooler version of itself, known as a white dwarf. White dwarfs are the remnants of low-mass stars and are extremely dense, with a mass similar to that of the Sun but a size similar to that of the Earth. An animation of a red dwarf evolving into a white dwarf. Larger stars, on the other hand, undergo more dramatic changes as they evolve. When a blue giant runs out of hydrogen fuel in its core, it begins to fuse helium into heavier elements, such as carbon and oxygen. An animation of a blue giant fusing helium into heavier elements. This process releases a tremendous amount of energy, causing the star to expand and become a red giant. An animation of a blue giant expanding and becoming a red giant. Red giants are much larger and cooler than their main sequence counterparts, and they shine with a reddish-orange color. They are also much brighter than the main sequence stars of the same mass. An animation comparing the size and brightness of a red giant and a main sequence star of the same mass. In the next segment, we will explore the final stages of a star's life and how they lead to its eventual death. In the previous segment, we learned about how stars evolve as they run out of hydrogen fuel in their cores. Small stars, such as red dwarfs, simply cool down and become white dwarfs, while larger stars, such as blue giants, become red giants. But all stars, regardless of their mass, eventually run out of fuel and come to the end of their lives. An animation of a star running out of fuel and beginning to die. When a star runs out of fuel, the balance between gravity and pressure is once again disrupted, causing the star to collapse. The collapse of the star's core releases a tremendous amount of energy, causing the outer layers of the star to be blown away in a massive explosion, known as a supernova. An animation of a star's core collapsing and a supernova explosion. Supernovae are some of the most powerful explosions in the universe, releasing more energy in a few seconds than the sun will release in its entire lifetime. They are also responsible for creating many of the elements that make up everything around us, including the iron in our blood and the calcium in our bones. An animation of a supernova explosion and the elements it creates. The remnants of a supernova explosion can take many forms depending on the mass of the star. For low-mass stars, such as red dwarfs, the remnants are white dwarfs. For larger stars, such as blue giants, the remnants can be neutron stars or black holes. An animation comparing the remnants of a red dwarf and a blue giant. Neutron stars are incredibly dense, with a mass similar to that of the Sun but a size similar to that of the City. Black holes, on the other hand, are even more extreme, with a gravitational pull so strong that nothing, not even light, can escape. An animation of a neutron star and a black hole. In the final segment, we will explore the role that stars play in the universe and how their deaths contribute to the cycle of stellar evolution. In the previous segments, we explored the different stages of stellar evolution, from the birth of a star to its eventual death. We learned about the main sequence, the longest stage in a star's life, and how stars evolve as they run out of hydrogen fuel in their cores. We also learned about the final stages of a star's life, including the supernova explosion and the creation of neutron stars and black holes. A montage of the different stages of stellar evolution, including the birth of a star, the main sequence, the evolution of red giants and blue giants, and the death of a star in a supernova explosion. But what is the role of stars in the universe? Stars are not just beautiful objects in the sky, but they are also the building blocks of the universe. They are responsible for creating the elements that make up everything around us, including ourselves. A shot of the night sky with stars twinkling, followed by a shot of the Earth and its various elements. When a star is born, it is made up of hydrogen and helium, the two lightest elements in the universe. But as the star evolves, it begins to fuse these elements into heavier elements such as carbon, oxygen, and iron. An animation of a star fusing hydrogen and helium into heavier elements. When a star dies in a supernova explosion, these elements are released into space, where they can be incorporated into new stars and planets. An animation of a supernova explosion and the elements it releases being incorporated into new stars and planets. This cycle of stellar evolution is responsible for creating the diversity of elements that make up everything around us, from the air we breathe to the ground we walk on. A montage of various elements found on Earth, including oxygen, carbon, and iron. In conclusion, stars are not just objects in the sky, but they are also the building blocks of the universe. They are responsible for creating the elements that make up everything around us, including ourselves. By understanding the life cycle of stars, we can gain a deeper appreciation for the universe and our place in it. A shot of the night sky with stars twinkling. Thank you for joining us on this journey through stellar evolution.